Okay, here's part 3. You might have an example where you have two images and you have to state what kind of transformation or the isometry that's mapped is the way they'll say it in the book. You have to identify the kind of transformation that it is, and you have to kind of say how it happens. You know, name the transformation type and then name the transformation that takes place, for instance, is what I would put. So the first thing you have to do is decide what transformation type it is. And the way that you'll figure this out is you have to ask yourself one question first. From black to blue, from pre-image to image, is this a direct isometry or an opposite isometry? In other words, can I translate and or rotate this image over here and have the same thing? And the answer is no. When I rotate or translate this, this ends up being a flipped image. So you already know that this is an opposite isometry. So that means I will either have to do a reflection or a glide reflection. And in this case, since it doesn't look like it's right over itself or whatever, like this one, I'll end up having to glide it over, translate it over, and then reflect it. Okay, so going back, let's figure out how we want to do that. So it looks like I wouldn't be translating it up this way because then I'll have to rotate it and then I'll have to reflect it. So it looks like I'll have to translate it underneath it first. So let me go and clone it. I'll make an orange one. And then I'll start, translating it over. So let's translate it over to the right here. 1, 2, 3, 4. There we go. 5 units, and now I'm underneath it. Okay, so now I'm underneath it, and now I need to flip it to, I need to flip it with an axis of symmetry that was parallel to my translation. So first let me name the type of thing. I'll just put GR for glide reflection, and I translated it um, 5 units in the X direction and 0 units in the Y direction. Now in this particular case, it's good that the slope is like that. The slope is 0. It's a parallel, or it's a line that's parallel to the x-axis. It's a horizontal line. So that means that my axis of symmetry will also be running like this. The question is, where is it? In this case, it's actually not on an integer. If I reflected it right here, that wouldn't make sense because my orange, like this point, for instance, would be up here. And it's not down here, because if I reflected it, this point would be right here on the line. So it's actually right in the middle, and you might have questions like this in your book, but it'll be at that point, on that line, that is y equals, let's say reflect over y equals negative 1/2. That means for every value of x, 1, 2, 3, 4, 5, etc., y is at negative 1/2. Because this point from this point is the same as this point to this point. And this point to this point is the same as this point to this point, etc. So just make sure that you understand a couple of things in this example. First of all, you had to figure out whether I had to rotate or translate this versus reflect or glide reflect this. And you determine that based on whether its orientation is the same or different. In this case, they're different because I had to flip the image. The other question that you ask is, and then you say, okay, it's a different orientation. You say, do I reflect or glide reflect? Well, this isn't really a reflection. Maybe you could make it a reflection, but in this case, I translated it first and got it underneath it so that I made it a mirror image. So you translate till you make it a mirror image, and afterwards, you do a reflection. Okay, and finally, just some examples just to see if you truly understand the direct orientation versus opposite orientation here. The following pairs of figures are congruent, so they are isometrics, but are they direct isometry or opposite isometry? Is one figure a translation image of the other, a rotation image, or neither? Remember, if it is a translation or a rotation, that means they have the same orientation, or they are direct isometries. If they do not, then they have opposite isometries. or they are opposite isometries, and they have different orientation. So, from this K to this K, is this a translation, rotation, or neither? This is a translation. From ABC to this upside down ABC, is this translation, rotation, and neither? Well, you'd have to pick a center point to rotate it about to check and see, because you know it's not a translation. And you're going to say, is it a reflection? Well, does this A reflect over this A? Well, not necessarily. Could it be a glide reflection? Let's see. I could flip this over. I could flip it over this line right here to make this ABC backwards, and then flip it over that line. But what's a composition of reflections over two intersecting lines? That is a rotation. So this is a rotation about this center point between B and B. So this is a rotation. And if you want me to explain these, when you explain, you say they have the same orientation. They are direct isometries. Have the same orientation, direct isometries. Finally, this last one, this says high and high again. It looks like it's a reflection across this line of some sort. I have that high and high. So if it's a reflection, that means a flipped image has different orientation. And that means it is neither a rotation nor a translation. A reflection is its own thing, so is glide reflection. Different orientation means opposite isometry. Okay, what are some real-world examples of each isometric transformation type we have learned about? A reflection, we've talked about this a lot before. It's like looking into a mirror. A translation is just, it could be anything. It could be driving a car. It could be walking. It could be anything that's moving, as long as you're facing the same direction. A rotation, you could say a merry-go-round. I wouldn't say Ferris wheel, because in a Ferris wheel, you always remain upward when you're on it. Either you're right there or you're right there. And remember, the thing about rotations is you need to rotate as well. So you'd be hanging upside down if you were on a Ferris wheel that rotated, per se. And a glide reflection, there aren't too many examples. The two I could think about, like an amusement park, is a roller coaster that does one of those inline twists. Or if you're walking in the snow and you're leaving footprints on the ground. So your footprint when walking right here, the bottom of your foot when walking is the normal thing, and as you're walking over and you look at your footprint down here, that should be a reflection of this footprint. So there aren't too many examples of that. And finally, I must advertise my YouTube channel here. I just made a tiny URL for it, Geometry Robinson 12. It's just for chapter 12 here and for you guys. It goes straight to the channel. That way you can see all parts of any videos. And if you have any other questions, please let me know. The homework is always in the comments section. In the information section underneath the video. So go ahead and check out the homework if you need it to. Okay, thank you.